Well, thank you so much for joining my session today. I really appreciate it. Hope you all had a great lunch and you're all energized and ready to dig in and talk a little bit about microservices, specifically for SaaS environments. My name is Todd Golding. As the slide says, I'm a partner solutions architect at AWS, and I'm part of a team that's called the SaaS Factory team. And that team basically works with customers and organizations that are involved in building and delivering SaaS solutions on AWS, anywhere along that spectrum. And what we find when we work with these customers and these partners is they're all very interested in just generally adopting cloud-native concepts. They're all chasing microservices and doing all the cool things that we see everybody want to do who's building just modern cloud-native applications. And this is a really good motion for them, and they're sort of all in with that, and they see that as fundamental to the success of their SaaS organization. However, along that journey, as part of adopting a microservices-based architecture, they're also finding that building and creating microservices for a SaaS environment specifically has some new twists to it. Right? It has different sort of considerations and different sort of realm of issues that you'll face. And so my whole goal for this discussion is to try to highlight for you some of what I see as I work with customers who are going through this process. What are the areas where maybe the decomposition of their system into microservices has to be a little bit different, or makes them think a little bit differently about what a good microservice really looks like, where the boundaries of those microservices are, and how we split them apart. And so we're going to dig into that concept. Now, I want to highlight that this is a 200-level session. And as a 200-level session, we're not cracking open the IDE. We're not going to be writing any code in here today. This is a conceptual a set of ideas about how to decompose services and how to think about what the right way you would find the boundaries of your services are in a SaaS environment. So if you came here with some expectation that we'd be digging into architecture deeply or showing you sample code, probably not going to be the best fit for you, and I won't be offended if you choose to go find more content that might be better aligned with what you want. But assuming that's all good for you and that's what you're interested in finding about, let's dig in a little bit. And before we can dig in and really start talking about the SaaS nuances, I feel like it's important to start with a foundation of just being clear that we all have the same idea and definition of what a microservice is. Because if you don't have that sort of foundation, it makes all the rest of this discussion much more difficult. And to me, I'm not going to tell you anything here new about microservices that you won't necessarily find out in the wild, but I think it's important that you get this grounding of these concepts. And to me, the most important part of a microservice is, I actually think of microservices as almost these sort of mini products. They are entirely autonomous. They're managed independently, they're versioned independently, they're tested independently. They encapsulate whatever underlying implementation they have, including, and this is super important in an area where people often trip up, including the underlying storage. Whatever storage is being used by this microservice is owned by the microservice. It's not owned by 10 microservices. It's encapsulated and owned by this one. In fact, the example I always give to people that is, if I wanted to change from relational to a NoSQL database inside my microservice, but didn't change anything about its contracts with the rest of the universe, that should be fine. I should not impact anybody else because my contract still remained intact. And when we talk about the contract, that's really our binding to all the rest of the universe in a microservices world. So here I've got an example of a few REST interfaces that are just like get, put, post, delete, just to highlight the fact that this is our contract. This is what we're telling the universe we're going to do, and this is what we're going to abide by as a microservice. So that is the universe of microservices. So then this begs the question, okay, why are microservices such a great fit for SaaS? And maybe the answer to this is a little bit obvious, because microservices probably, if you've been in them at all, are just really just a good fit for any environment where I'm looking for like good scale, good availability, good deployment sort of model. But there are specific reasons why I think microservices are also a good fit for SaaS. And certainly at the top of that list, and almost everything you'll hear me talk about here and prior reInvent talks, is this notion of agility. To me, if I'm building a SaaS solution and I've chosen to build a SaaS solution, I've chosen it because I want to be more agile as an organization and as a business. I want to release more frequently. I want to push features and functions to customers at a much more rapid pace. I want to be able to go from an idea all the way into the customer's hands as quickly as possible. And I want to be able to have an entirely enriched business model that surrounds that in a way that says everything about how we build and release and support and operate our business is all about the speed at which we can do it. And to me, microservices are fundamental to achieving that goal. It's hard to imagine for me, in fact, building a really large solution without some microservices-based approach, just because it would be really hard to reach some of your agility goals. The other aspect of this, and these kind of overlap with agility, is the fact that microservices give us smaller deployments, right? Just because we're working now with a smaller unit, we're moving away potentially from monoliths and these big, large units of deployment where we had to test them really heavily, their coupling was really complex, and it was really hard to push things out. Well, now, just by breaking things down into smaller pieces, we get a smaller blast radius for everything we roll out, and it sort of promotes this idea that we can release really frequently because we're less worried about the impact of the thing we're releasing because it's small and self-contained enough. Now, another one a lot of people don't think about, especially because this probably has more of a SaaS twist to it than others, is this idea of sort of optimized consumption. And what do I mean by optimized consumption? What I want to say is in a SaaS environment, I want to, across my entire architecture, always try to find a way to align tenant activity and tenant consumption of my resources with the actual amount of infrastructure I'm provisioning to support those tenants. And it's a constant battle in SaaS environments to find that balance where you're not somehow over-provisioning because you're just worried the system's going to fall flat on its face, so then the cost of your infrastructure going up and so on. We're always chasing that alignment. In fact, I do whole talks on just that subject. And really, our goal here is to say with microservices, we get more knobs and more dials and the finer granularity of microservices. Let us really tune the amount of consumption and activity of tenants and match them to the appropriate amount of infrastructure, hopefully without needing to over-provision nearly as much. We also get a slightly different DevOps experience, hopefully, here from microservices that's super helpful to SaaS environments. Yes, we're just going to build pipelines, we're going to roll out deployments, we're going to have the traditional moving parts of a DevOps experience, but in a SaaS environment, imagine you have 1,000 customers all running in a shared environment and you're doing a deployment. Well, that deployment, when it goes out, right, you're going to have to get a reaction from your customers. Do they like the new feature? Do they like the new function? Do they like the new capability you just pushed out? And this is where using things like canary releases, A/B testing, a lot of these mechanisms that are talked about in the DevOps world, they really come to life and shine inside a SaaS environment. Because I can imagine if I have 1,000 users all in a common environment and I can push out to 10% of them some new feature, get their reaction to it, and then, oh, they loved it, let's push it to the other 90%, or no, they don't like it, let's iterate a little and try again. This becomes a backbone of a really valuable mechanism where you can experiment a little bit as you roll out features and functions. So to me, having microservices and being able to deploy in these smaller units and then canary test in these smaller units, this all sort of ends up combining to make a very powerful effect. Just generally, you can imagine in a SaaS environment, we need zero downtime. We want to have a model where we're not saying, well, we're down for 4 hours while there's a maintenance release going on right now, which is the traditional monolith kind of model. And just generally, because we're in this microservices model, because we have these smaller deployments, all the things we're sort of talking about here, we end up with a model that is much more conducive to a zero downtime goal. And finally, the last one, it might be actually the most important one on the slide, and the one that people don't necessarily talk about is, if I'm doing microservices, and teams own their own microservices, and these services have their own autonomy, and hopefully, once we've invested and built our DevOps pipeline, and we've done all the goodness around this, we can focus less on all the complexities of infrastructure and just keeping the system running, and instead pay more attention to the features and functions of our product. Because really, that's where our success lives as a SaaS organization. How much of our time is spent talking about features and functions and new capabilities versus just trying to keep the system up and running? Now, I've put two contrasting models here to try to drive home the idea that SaaS microservices have different set of considerations you want to think about. And to do that, I start with a single-tenant model, like a traditional single-tenant model where essentially every single customer's getting their own stack of services. Yes, they're running cloud native, they have microservices, they're doing all those things, but every single customer's getting their own environment stamped out, and they're running in complete isolation from one another. And if you think about the mindset for microservice decomposition when you're building for this type of environment, your universe is much simpler. I don't have to worry nearly as much about things like noisy neighbor, how much does this one affect this one? I don't have to worry about if some outage happens in one customer, it's not going to potentially cascade across all the customers and take everybody out. I don't have to think about activity and really modeling tenant activity and figuring out what are they doing, how are they using the system, and what are their consumption patterns, because they live in a much simpler environment and a much more controlled environment. This even makes scaling easier, right? Because the activity is more modest and more controlled, coming up with what the right scaling policies in here is also a little bit easier to do. Now, take this single-tenant model, and now let's project that forward to what a multi-tenant SaaS environment looks like. In a multi-tenant SaaS environment, now all of these microservices are shared by all the tenants of my system, potentially. There's all kinds of variations of that, but let's go with this one as the one we're using for the moment. And those tenants will come in all shapes and sizes. Some tenants will have a massive data footprint, but only use this much of the system. Some tenants will have a really tiny data footprint, but they'll push the compute of the environment like mad. There's a full spectrum of ways that these tenants are using the system. And more importantly, new tenants are onboarding all the time. If you've done a good job with SaaS and you've done frictionless onboarding, new tenants are showing up, they're coming in, and so the profile of how tenants are using your system is changing all the time. Well, now all these things that were sort of easy for us when we were in the single-tenant model now are more complex for us, and they in fact change the way we think about decomposing microservices. Noisy neighbors, super important to us now. I have to think about how one tenant could potentially impact the performance and the experience of another tenant, and think about whether or not the way the services are decomposed is creating bottlenecks for tenants in ways that I hadn't anticipated, that I didn't have to think about in the single-tenant model. I also have all these issues of shared resources and isolation I have to think about. Now when I'm in here, for some of these microservices, and we're going to get into this, some tenants are going to expect that their resources are isolated from one another. Well, what does that really mean, and how does that affect the way I decompose the services? That's like a huge conversation for almost every SaaS organization. How are we going to achieve isolation? And you better bet isolation absolutely is going to affect your decomposition strategy, right? And then even scaling is more difficult in here, because even during a certain time of the day or a certain day of the week, we find that the activity is varying so widely that predicting and assessing scale here is really hard. And so we have to look at strategies and decomposition strategies that'll help us with that. And probably one of the bigger ones here is this notion of blast radius. Now, if something goes wrong in here, and one of these services goes down, and if that takes all the other services down or takes the system down, my entire business is down. So we have to now think in our decomposition model, what can we do in our decomposition strategy to try to limit the blast radius of these microservices in a way that the system can stay alive even when bad things are going on. Now, before we dig into some of these, I definitely want to talk about, well, where would I start? If you said, Todd, go away, design the microservices for my system, we're starting from scratch, I'm not going to do something wild and exotic and different from what I would do in a non-SaaS environment. I'm still going to ask about your domain. I'm still going to say, what are the domain objects? What are their interactions? What are the common sort of models for how you would think about the interactions between the different objects in your domain? And some organizations will even just say, well, now I've got those objects, and they'll do subdomains. I've oversimplified here. They'll break product potentially apart into 3 different microservices or whatever, but they'll do a pretty literal translation of the domain objects into actual microservices. And generally, this is where I think just generally systems have problems with this approach to decomposition, but I also think SaaS environments really have problems with this decomposition model because it doesn't factor in a lot of the things we've been talking about here. Where's fault tolerance in that decomposition strategy? No customer's gonna tell you, I want a more fault-tolerant product service, right? Only you know that I need some aspect of this product service to be more fault-tolerant. They're not gonna tell you, hey, I wanna be sure this microservice is not as noisy neighbor. Only you are gonna come up with that. And so you have to layer onto all of this, all of these other considerations to figure out what's the right services. And in fact, I will tell you in environments where this goes really well, there's often services that come out of this that have names that look nothing like anything a customer would ever say. So ultimately, my point here kind of along the bottom is it's perfectly fine to think about the user's domain and the user's sort of sphere in terms of whether or not, these are the right microservices, but don't forget that we have to think about the operational sort of notion of these services as well and make that important to us. Because to me, again, I'll say it 100 times in here probably today, but when I put all my customers in a common environment, the stakes are just so much higher. So what are the techniques that are out there that people are using? Certainly you'll probably see this all over. This may not even be new to you, but you'll see people using domain-driven design, even though I think domain-driven design really wasn't originally meant to have anything to do with microservices. It seems like it's evolved into that. People doing stuff with business subdomains. You'll see this mechanism called event storming that is used to come out and find the microservices that are in your system and help with your decomposition. I think event storming is a little more recent mechanism. There's probably like 4 other methodologies I don't know about that are out there that people are using. And I would say to you, if those work for you, awesome, go grab them, go use the materials that are out there to help you find your microservices. But on the list of things you have and the list they give you for thinking about your microservices, add all of these extra SaaS considerations to your microservice story. Add the bits we're going to end up talking about here to that story, and test against that as a boundary. So I'm gonna outline just a few of the key areas that I think were the ones that stood out to me as good areas to sort of dig in and talk about how decomposition is affected in SaaS. The truth is, it's a pretty broad subject, but I think these are the core areas I would tend to focus on. Certainly, I've already hammered this home. Tenant isolation is absolutely fundamental and should play a huge role in how you think about how you decompose your services. Bulk operations is an obvious one, but one that people don't always address. In a multi-tenant environment where I've got these services and some tenants want to make API calls and they want to do it in a bulk manner. So if they do it in a bulk manner, they have a potential to affect the SLAs and create noisy neighbor problems, so what do we do about that? The other one, and I'll beat on this one a lot because I think it's super important, is this notion of fault isolation. How can we build a set of services that will be resilient in a way that will keep our system from having the kind of outages that will happen where the decomposition hasn't thought about resilience and fault isolation? Data partitioning, how we separate the data for tenants, how we pull them apart, and thinking about what that might mean in a noisy neighbor context and what it might mean in an isolation context. In fact, you'll see some bleed over here from data partitioning to isolation. That's just natural, but we'll talk about how do you represent data in microservices in a multi-tenant model, and how does that affect the way you decompose your services? And then lastly, we'll talk about tenant tiering, like this idea of tiering, basic, premium, advanced tiers, and those bits, and how tiering potentially affects the way that you decompose your services, along with a look at metrics that I've kind of bolted onto that and say, how do metrics also guide the evolution of your microservices? Because to me, you don't just have day one, have your microservice and you're done. You have to think about what the evolutionary path of those microservices is as well. So let's start with this notion of isolation. And when we look at isolation, what I tell organizations who are decomposing their system into microservices is to use like this agile mechanism that's out there already. If you've used agile, you've seen there's just general agile methodology has this notion of personas. I want you to go build personas for your tenants. And I don't mean you need 50 personas. You might have 2, you might have 4. But who are the different kinds of tenants you're going to have? And what are the different expectations of those tenants? Specifically, what are the different isolation expectations of those tenants? And I've got 2 examples here I just provided as extremes that could both be valid for a single product. On the left is the example of some highly compliant, maybe enterprise SaaS-y kind of customer that is all about isolation. They won't buy your system if you won't guarantee them isolation. They've got all these worries and concerns, and the only way to close the deal with them is to give them some sense that some or all of the system is isolated in ways that will meet their compliance needs. On the other end of the spectrum is somebody who says, I want compliance just like everybody else, but I trust that whatever you're doing under the hood will assure me that I have compliance. But I'm more interested in how fast can you get me features and functions? How much does the product cost? How quickly can I onboard it? I'm more about the value I'm going to get out of it, not just about the isolation. And somehow, if I want to sell to both of these, I have to think about how that would affect the isolation model of my system. Another area where we see isolation playing a role is just in the deployment footprint of your microservices, right? Some people think of isolation as an all-or-nothing world. It isn't an all-or-nothing world. I can say some of my system runs in a shared model. We call that a pooled model, where tenants are running in a common environment. And some of my system can be running in what we call a siloed model, where every tenant has their own infrastructure. I don't have to say you're all or nothing in one of those 2. And that affects the way we decompose services. So now when we're decomposing a service, we can say, for this service, could some part of this service meet the isolation needs of a certain tier of tenant or type of tenant if it were deployed independently, whereas the rest of this service could potentially run in the pooled model. And what you're going to see me pushing for is I want to put as many things in the shared model as I possibly can, because on that side of the house, the agility story is so much easier. When everybody's running in a shared environment, management and operations is easier, DevOps is easier, everything's easier. As soon as I start distributing more and more services on a per-tenant basis, the complexity of my environment gets higher. So I'm going to, as I'm decomposing, I'm going to be saying which things go over to the isolation side and which don't. And as part of that, I'm going to actually go here. You'll see that I've taken these simple e-commerce concepts and I've said that I have these product, this order, and this cart service. And for whatever reason, I've said my customers won't buy this, or some set of my customers won't buy this unless this particular functionality runs in complete isolation. Okay, I'll deploy those services in complete isolation from one another. But I'm also going to have a set of services that run in this pooled model, this shared model. And then I'm just going to always challenge myself, even on each service, to say, well, this is a really good service. It makes really good sense from a domain perspective. Yes, but what does it mean from an isolation perspective? Could it be split in a way that might give me value and agility from the isolation side that's important to me? The other bit that here, and this one seems like it isn't an isolation story, and it seems like it's not a decomposition story, but I assure you it is the use of isolation constructs. What do I mean by that? Well, when we build a SaaS system and we're trying to build isolated microservices, we have to ask ourselves, how will these microservices truly be isolated from other? Not just based on their deployment, but based on the security mechanisms we apply to those services. So, IAM. Just like in most of the AWS universe, we use IAM to control the flow between 2 services and be sure somebody can't cross a boundary. Here I can use IAM constructs with my microservices to ensure that one microservice can't somehow cross a boundary to another. But depending on how I'm decomposing my microservices, those IAM constructs can be used differently. So in this left-hand side, what you'll see here is I have 2 order services. They are fully siloed, and here I can just use an IAM role, and the IAM role will essentially let me control the whole scope of each one of those services to ensure that that service can't cross a boundary. But when I get on the other side of this and I have a pooled or a shared microservice where multiple tenants are sharing that microservice, I can't now have just a single execution role for that service. I have to have a much broader IAM scope because that service needs to be able to talk to all the resources available to all the tenants. Well, now I have to do more clever things at runtime where I have to go out to IAM and go get a token based on who you are and what your identity is and what role you're in and use that in my code to ensure that you're not crossing a boundary. A much more complex story. And so my point here is, as you're decomposing, you should be asking yourself, okay, I need isolation of this service. What are the different tools I'm going to use to enforce that isolation and what's available to me? And will that level of isolation with that isolation construct, with that IAM role or policy or some third-party security mechanism be enough for me for that service? Or do I have to decompose it differently? And just to drive home this experience a little bit, you'll see an example here of a Lambda serverless sort of SaaS environment here where a tenant has their own stack in what we call a silo model here. And here, because this tenant's running Lambda functions that are running on behalf of that tenant, I can actually deploy these Lambda functions with an execution role, and that execution role will say, now for the life of the execution of this function, it will have to comply with those IAM policies as it tries to touch any other resource. Really powerful if I'm trying to achieve isolation. So now as I try to go down and touch S3 buckets or DynamoDB or Redshift, it's going to challenge me all along the way and say, is that a path? Can I follow that path? Am I allowed to cross that boundary? And to me, that's very reassuring, even as I talk to customers about how safe is my data, how protected is this environment. That story is entirely different in the pooled model. In the pooled model, I come in, now I have this Lambda function. This Lambda function, it can be executed by any tenant in my system. So as I get into that function, I actually have to go out, and I actually have other sessions where I get into great detail on how to do this. I have to go out to IAM and use your identity in the context of that call to go figure out what is the scope of your access, what are you allowed to touch, get a token back, and use those credentials in my code to then go access all the downstream resources. For me, that sounds like an entire discussion of security and IAM, but it's really, to me, an isolation story and a microservices decomposition strategy, because I want to end up with a model here and a isolation model that uses the constructs that make the most sense to the service I want. And if I've got a service that has got a really high isolation boundary, I might opt for a different set of tools for security, or at least look really hard to verify that there's some IAM mechanism or some third-party mechanism that will really let me lock down that service. The other area we said we'd talk about is bulk operations. This one, again, pretty straightforward, but it's one that people have to think about. Like, you'll build a microservice. You'll think that microservice is a perfectly logical microservice, seems to make sense. But then in a multi-tenant environment, somebody will choose to use the API of your microservice in a way you hadn't expected because they really see it as a way to do bulk operations. So then what they do is they start making excessive number of calls to some entry point. That starts essentially saturating the service, and now we have to either scale the service or we have to figure out what we're going to do to try to make sure we can still meet the SLAs of other tenants or not over-provision the environment just based on this one tenant's activity. And the solution to this isn't particularly exotic, but it's the only one I've seen that we've been able to leverage that seems to make sense to me. I'm looking for better ways to do this. In fact, if somebody has an awesome way to do this afterwards, I'd love to hear your thoughts on this. But I was at an e-commerce SaaS provider, and we had the notion of a product catalog. And we had these providers who would update their catalog, and they'd make a few update calls or a few hundred update calls every day, or they'd do different things to update the state of their catalog, and that service scaled perfectly fine. But then we had these really small providers that were only paying like $39.95 a month. They didn't really know how to use the API. They had 100,000 products in their catalog, of which they probably sold a few a day. And their way of updating the catalog was to re-update all 100,000 products every single time they wanted to update the catalog. So our system would take this 100,000 calls of API calls, then it would saturate a service, then we had to go scale crazy, or we ended up with latency issues because other people were affected by the noisy neighbor dimension of this. And it was really bad. And by the way, they were paying us $39.95 a month and affecting the person who was paying us $100,000 to run the same system, right? Not really a great experience here. And so what I've said it is, I really want to be very explicit about separating the bulk operations out from the day-to-day transactional operations. And even if that makes things more complex, it's a better operational story for my overall system. So I'll push the bulk operations over there. I'll even then put throttling and other things over there to say, yes, you can call, and based on the tier of tenant you are, I'll let you call, with a certain level of frequency, and so on. And then ultimately, what I'll have to do, should go back there, sorry, I went too fast and forward. Ultimately, one thing I'll have to think about here, though, that I sort of overlook in this story is, if I'm doing bulk upload to this service, and the catalog item's actually in there, but ultimately they need to end up in the database of the other service, I'm still gonna have to have some way to move that data across between these two services in a way that isn't super chatty or doesn't somehow end up creating the same old bulk operation problem again. And so you do have to get kind of creative there. Usually you'll find people with some kind of slow feed synchronizing the two services to get the data moved from the bulk environment as a staged environment into the final environment. Now, the one, if you were to take no other advice from me from this session, the one area of advice I would really like you to focus on is this notion of fault tolerance. And to me, fault tolerance is always a complicated discussion because the mechanisms that are used to implement fault tolerance aren't easy sometimes. It's often very difficult to build these super fault tolerant resilient systems. But now imagine you're the person who's running a big SaaS organization with 1,000 customers running in there or 10,000 customers running in there, and some small parts of your system are failing here and there, and because they're not separated along any kind of fault boundaries, when that little aspect of your system, which may not even be critical to the overall experience of your customers, goes down, it cascades through your system and takes the whole system down. So then you spend week after week chasing these little problems because you can't really keep the system running in a really healthy way. I'm saying, even though it's hard, I really want you to invest in saying, when I decompose my SaaS microservices, every single service I'm gonna ask myself, is there some part of that service I could carve out and I could say, you know what, if that part of this service went down, is the system really down? No, I think I could keep running even if that was down. I'd have to be creative about what I would do, but I could keep running. Okay, then I'm gonna do that. And that might mean I have to implement all these clever mechanisms to do that, and I have to do async, and I have to have fallback mechanisms. I have to retry when the service is down, to do all kinds of clever things to get that to work. And I would say they're all worth it. And I've sort of created an example here that's maybe a little contrived, but Netflix was great at this notion of building resilient microservices. They've got really good sort of open sourcey bits that are all around this topic. And imagine in the Netflix environment, you have to stream movies as a business, right? Well, certain services that are supporting that ability to stream movie are probably absolutely mission critical. If I can't stream my movie, I probably am not gonna consider my system functional. If I can't get to my account and do the bits to validate your account and do your credentials, that might mean I'm not in a healthy state. However, if I have something like ratings, what are the ratings for a movie? Do I care when I'm watching a movie if the ratings for this particular moment aren't showing, or they're not showing me the most recent ratings, they're showing me something it cached from 2 hours ago when the system was healthy? I'd be perfectly fine with that. Same thing with favorites. Like, I've marked some of my items favorites. Well, the favorites part of the system is now down for some reason. Okay, that part's down. We have to figure out in a resilient way how to keep running while it's still down. And I feel like for a SaaS environment, because of the impact of a system going down, it's so high and it touches all of your customers that I will choose to break out services this way, even if it's a little bit unnatural. Like, if I have to push some data into another service because that service can now be more resilient as a result of that, but I get a little bit of replication of data between those services or something of that nature, but it gives me this much better fault tolerance profile, I'm probably gonna do it. Because to me, the operational profile of what I'm doing is more important to me almost than whether I've nailed the microservice and I could show it off to everybody as this awesome, great microservice. Now, there's lots of good data out there, fortunately, on this topic. I have not created any of these ideas as much as I'm advocating them for SaaS decomposition here. So there's this notion of bulkheads, which I really like. I wish I knew more about ships to be able to describe it to you really well. But the idea if I have a ship here and it has these compartments in it and they're separated by these bulkheads that define each compartment, and somehow some part of the ship gets damaged and fills with water, that the rest of the ship will still be able to float because the bulkheads prevented the water from crossing the boundary and going into all the other bits. That mechanism to me is the exact sort of metaphor we're after here with building these resilient services, right? And this is where we'll look at fallback strategies. If you haven't seen circuit breakers, I recommend you go look at circuit breakers as a way to look at this and think about all this in the context of decomposing your SaaS services. So this isn't, just like I said, the previous thing wasn't just about security. This isn't just about building cool cloud-native fault-resilient services. It's about building services that will keep the lights on at your SaaS business. The next area we'll look at is data partitioning. Data partitioning is interesting because we just generally in the universe of data partitioning always have to decide how we're going to represent individual tenant data. And there's two pretty common flavors. On the left, you'll see the silo model where every tenant essentially gets their own logical database. That could be separate DynamoDB tables. It could actually be separate RDS instances. Whatever it is, they have some notion of a separate database per tenant in that silo model. And then in the pool model, we have some model where we're basically saying every tenant is running in some shared database construct, and we've used some kind of identifier, a tenant ID, to identify which items in that construct belong to each tenant. And as we're thinking about decomposing our system and decomposing our system into these microservices, we have to ask ourselves which flavors of data partitioning are going to be appropriate for this particular microservice. And the truth is, there's a hybrid model that I just can't fit on the slide here, which is I really could have a service that has some of the data stored in a silo and some of it stored in a pool, all in the scope of that one service. But for me, one of the things I don't want people to do, and the mistake I see most people make here is they will say, I've got this really big domain of data. We've already today run all these queries against this data. This data is clearly all interconnected in a way we could never pull it apart. And customers need isolation, so I'm just going to give every customer their own database, and it's going to be the same old big set of tables. It's these 6 tables that we've used forever, and that's my microservice. I want you to challenge yourself to say, can that data domain be pulled apart? Is there some of that data that could be pooled and some of that data that could be siloed? And I ask that question partly because, again, I'm pushing towards the pooled model because we get advantages out of the pooled model. Imagine this pooled model on the right-hand side is a DynamoDB table, schemaless table, and if somehow I want to change the representation of the data in there and all tenants are in it, imagine the DevOps work to roll a release out and a change out to that. Not so hard. Imagine the management profile of that. Not so hard. I look at one view of that data for all tenants. Now take that same mindset and think about it where, I've got 1,000 tenants. They all have their own tables, their own database constructs, and I have to now apply all of that across all of them. So for somebody to be siloed, there has to be good reasons. So then in the middle here, I have a set of reasons that might push you one way or the other. Performance is a really good one here because for some domain of data, if it's a really large domain of data and I'm querying that data and I'm doing these really intensive operations with that data, putting them all into the same table might not be a good idea. One tenant could easily have a noisy neighbor kind of impact on another tenant. So if that domain of data has that sort of profile and we're querying it heavily all the time and we're doing those bits with it, I might say I'm gonna silo based on that alone because it'll never meet the sort of performance requirements of my actual customers. Then I might do that based on isolation reasons and compliance and security. That might push data into a separate realm. And then even the distribution of the data. How big is the data? What's the size and footprint of that data might influence how I separate it and put it into separate microservices. Ultimately, what I'm really trying to get people to do is say, try to think smaller about your data. If you have existing data, if you're greenfield, this isn't so hard. But if you have a really big existing relational database and you've got a big old monolith sitting on top of it, the hardest thing for people to do is imagine that database pulling apart into microservices, and yet that's what you have to do. And so what I have, simple example here where I've got some data domain, and I looked at it and I said, you know what, in that data domain, there's a set of data families, and 2 of those families, 1 and 3, are really tightly coupled. They're really joined at the hip. It's really hard to pull them apart. I'm gonna put them all into one microservice. By the way, they also have some kind of profile for isolation maybe that pushes me that way. But data family 2, it's not even big data potentially, doesn't really even have a key isolation dimension to it, and I could push that into an entirely separate microservice. The other area of data that people don't think about when they're building microservices is they don't think about versions beyond the first version. And specifically, they don't think about what it's going to mean to migrate that data as you roll out new releases. So for me, each time I'm building these microservices, I want to think about what the migration story of that service is going to be, and am I comfortable? Is it a good story? Is this service going to be changing all the time? Is the data structure going to be changing all the time? How am I going to do it? I don't know if any of you have ever tried to write the code that's needed in a DevOps pipeline to migrate data in a relational environment where I've changed the schema and I've got 1,000 customers currently running against it and I'm trying to have 0 downtime. That's not an easy process, right? So I'm going to take all those factors and I'm going to bake them into my decomposition strategy as well. Think about data migration and how it would influence that. The last bucket we have here is tiering, and I bolted, like I said earlier, metrics onto this. And I find with organizations that are just moving to SaaS, they have a tendency to sort of think of tiering as somehow outside their scope. Like, yes, eventually the business is going to have some idea of what the tiers will be, and we'll figure out what that is going to be, but that's a pricing mechanism, and it has very little to do with how I decompose services. I actually believe that tiering can have a really big impact on how you decompose your services. Imagine I have this premium user, this premium tenant, and that premium tenant, there's some differentiating factor that said you're premium and we're going to let you do things that a professional tier can't do. Well, to make those things available, I may have to partition in ways differently so that a deployed set of functionality or capability for that premium tier will be deployed with a slightly different footprint than it is for the basic tier, right? So I really want to say to the business, like, what are the differentiating factors between the tiers of the system we're going to have, and how will those differentiating factors potentially change the way I pull the system apart? And I've sort of built up a bit of an example here where I tried to show the difference between a basic and a premium tier. So on the left-hand side, you'll see sort of the activity of the basic tier, and on the right-hand side, you'll see the activity of the premium tier. And the thing that should hopefully jump out to you if I've done a decent job here is that the premium tier is more, they're kind of a batch-oriented sort of, and they're more about inventory and volume updates to inventory, and a lot of their activity is around inventory. And what we find is this is common to all our premium tier users. They're very interested in batch updates and heavy demand on the inventory part of our system. And so if I want to make their experience different than the basic tier, and I want to offer them better throughput and a better experience and something they're willing to pay more money for, I'm going to take this product management service and say, you know what, I'm going to make I'm going to split that into 2 services. I have to hope that when I split it into 2 services, didn't create this really chatty model between the 2 of them, but assuming they could be split apart this way, by having this inventory service as a separate service, I now have the option to go deploy that service as an isolated service just for my premium tier tenants, and give them better SLAs, give them better throughput, turn up the dials and knobs on the scaling for them, and then tell the basic tier, hey, you're all going to run in the shared environment. I'm going to optimize for cost for myself there. I might even throttle your experience a little bit there. And if you want more and a better experience, that's why you move up to another tier. So it becomes a super powerful construct. So I encourage you to look at how tiering lands in these spaces. The other bit, I tend to really push on this really hard is, I really want you to use metrics in your microservice decomposition experience, right? If we have all these tenants who are all running in this shared environment, and they're all using our system in different ways, as much as we spent time on the whiteboard trying to find the right microservices, and as much as we worked really hard to sort of create this really nice microservice deployment, the reality is until real customers and real tenants are exercising those microservices, you don't know if you got it right. So the only way to sort of find out if it's right and adjust and evolve is to wire up your microservices with as many metrics as you can, and those metrics should have tenant context and tier context attached to them so you can see how not just tenants in general are consuming your system, but how different types of tenants are consuming your system. And I guarantee you, when you get to that state, you will see that, wow, this decomposition wasn't quite right. I don't know anybody who gets a microservice decomposition right on day one. It's just a lot of work. So just count on the fact that it's not going to be right, but then give yourself really rich data to look at about that microservice so that you can get some sense of how you would evolve it and split it into two, combine some microservices, do whatever you want. So I came up with this really sort of cheesy dashboard that I wish I had, which was, and maybe it can be built with some of the tools that are out there pretty easily, but I said, imagine I had this view of all of my microservices, and it had some notion of health attached to those microservices. And then down the left-hand side, I could filter based on the different types of activity that were going on with those services, and more importantly, I could filter based on the context of actually individual tenants or tiers of tenants. Well, now in this model, I could be looking at this, and it all looks like, hey, everything's kind of green. Most of these services are doing pretty well, but now I drill in a little more and I go look at a specific tier. I go look at the advanced tier of my system and I look at the services and I see that there are certain bottlenecks that for the advanced tier are showing up as a problem, but in the aggregate of the whole system, they're just kind of yellow or moderately green. I need this kind of data to say something's wrong for this particular tier. And then you can see below, I didn't do the animation in here, I could even drill in to say, tenant one, what's going on with you? Tenant one's doing something and they're having a rotten experience, but I've done all this great job of decomposition. Is it working? Apparently not for tenant one. Why? This next topic is one that I had no home for, so I put it here in the slides, just hoping that it would resonate with you because it's still something I think you need to think about, which is when you go away to build your SaaS solutions, you are picking a compute model. Your EC2, your containers, your serverless, you're one of these compute models or a mix of them. And my point is that there is some correlation between the compute model you pick and the decomposition strategy you choose. To make that example, let's look at a container. Here I've got a container, I've got some order service, and it's got a series of functions that it supports. Add order, get order, create order, and delete order. And what I see here is that the create order part of the system is the part of the system that's always getting hammered. But my unit of scale here, if I want to address this, is I have to actually add just more containers. The only way to solve this create order sort of bottleneck is to just scale the number of instances here, which is a perfectly valid thing to do. But it's also going to make me ask, is my decomposition right? Like, is create order, or does it somehow need to come out? Does it need to scale independently? Would that be a good experience? And there's a whole lot to think about there. But take this same model and say that I have that microservice, but now that microservice is running in a serverless environment. And now each one of those entry points is actually a Lambda function. Well, now because these are Lambda functions, yes, they still are scaling differently, but I don't worry about it as much. I don't have to change my decomposition because the unit of scale is each one of these individual functions. So if I don't touch add order or delete order, I just won't consume any resources. There will be no impact of that. And if create order gets pushed really hard, Lambda will just scale out to meet the needs of create order. So I'm fine sticking with this decomposition. It seems to work for me, and it works in the context of everything else my system is doing. But on the container side, I'm going to have to think a little bit more about whether or not this is decomposed properly. Another key point I'd really like to drive home here is that, like, everybody will always ask me, like, what's the right size service? Like, how big should a service be? And for me, there is no answer to that question. It just depends on what your system needs to do. And I always say to people, if you're just starting, especially if you have an existing system and you're like, we want to move to microservices, we have a whole workshop that's just about doing that here in the SaaS team that is working on this exact problem. And I want to carve out that first service. I'll tell organizations, build this coarse-grained service. Go ahead and start there. Because you don't really know. Maybe that coarse-grained service will be enough, right? But then if you find out there's bottlenecks or natural divisions in that service, go ahead and carve it out. Separate it into a couple microservices. And maybe you'll stop there. Or maybe you'll find out, no, in fact, this big old coarse-grained thing split into 4 services. Maybe that's fantasy. Maybe it's not 4. Who knows? But the good news part of this one, and the one that everybody misses in this story, is because everybody just presumes this is going to be the evolution. Sometimes the coarse-grained service was fine as it was, because it wasn't a big part of the bottleneck of the system. It wasn't doing anything exotic. And yes, it has too big of an interface, and it doesn't have a lot of the bells and whistles that everybody wants to say makes a really good microservice. But if it's getting called 1% of the time in my system, and it never is a point of failure, and it's never a big issue for me, maybe it's okay. The other piece of this is, and it's sort of connected to this idea of coarse-grained a little bit, is I really think you ought to have this notion of fail fast attached to your microservices decomposition strategy, especially in a SaaS environment, right? I have been in organizations where they have gone away and their architecture team has spent 3 months producing 60-page document with sequence diagrams and all the sort of traces, all the activity of their system, and they haven't written a line of code yet because they want to be sure they got all those microservices right. I don't know that that will ever get you any closer to the right set of microservices. I'd say do the work. Certainly make the investment in trying to find the right microservices, but don't go over the top there. Instead, what you need to count on here is you need to count on building a really rich microservices development experience so that the creation of a new microservice, the splitting of a microservice into 2 microservices, and the publishing of all that in a DevOps pipeline and all the versioning and all the work around all that, if you've got all that done well, then suddenly when somebody says, this microservice shouldn't be this way, it should be split into 2 or split into 3, you don't go, wait a minute, that's going to be this huge effort to split it apart. Yes, it'll still be a lot of work, but most people are thinking it's a lot of work because it's just so hard to get a new microservice all the way through the pipeline. And so for me, I say invest then in those tools, invest in making that richer experience so you can free yourself up here to say, we've done enough homework to think this is the right microservice. Go write it. And then, yes, if it's wrong, we'll evolve. But don't sit there and try we get one chance to get it, and that's all we've got, so let's think about it as long as we possibly can. So key takeaways, and these will probably all be just a reiteration of the points we've already hammered home here. But certainly, I hope you see that deployment and isolation, that whole discussion we had at the beginning, those isolation profiles of your tenants, the look and feel of those tenants, their expectations for your domain will absolutely have some impact on your service decomposition strategy. And this one about pulling your data domain apart, I think people don't take this one seriously enough also, which is challenge yourself. Let go of some of the things that have been tightly coupled in your past. Don't hang on to the normalization of data, for example. Sometimes to get really good resilient systems, we do things that aren't fully normalized, and that freaks people out sometimes. But it's sometimes what the right thing to do for your system. Put tiers and SLAs and performance and all those bits into your service decomposition strategy. Think about tiers. Ask the business, what are the tiers? How are we going to distinguish the tiers? And you might actually force them into a model where they'll actually come up with creative ways based on what you're feeding them to say, hey, we could actually make it so doing this is a richer experience, and that would create an opportunity for tiering. Fault tolerance, I think I beat that one to death. I won't say anything more about it, but trust me, go away, put fault tolerance in your equation, and then whatever you do, put the metrics in there. Don't just trust you got it right and then go to the console or go to some high-level monitoring tool and just hope that you've somehow done a good job and expect that's going to tell you enough about whether your service decomposition is right. And do it all with tenant context. I think we talked about this. Definitely open your mind to coarse-grained services as a starting point. We definitely think that this is not a one-time event and that you'll get lots of opportunities to enhance. But hopefully overall, for this entire discussion, I'm hoping that you can see that SaaS absolutely brings with it a set of considerations and a set of sort of operational considerations, isolation, all these things we talked about that should influence and shape your services. It won't change everything about how you do it, but it will influence it, and you ought to be thinking about that from the beginning. Now, just quickly, there are some other sessions going on. I have a serverless SaaS breakout that's going on if you're interested. I think the other breakout already happened. We have a series of chalk talks, metrics, monolith to serverless SaaS. We have workshops that are out there. Hands-on SaaS is out there, a really awesome one that takes you end-to-end, or a workshop that takes you all the way through the monolith to serverless SaaS lifecycle. That's a really cool one if you're thinking about it. And that monolith to serverless SaaS actually moves the monolith over and then starts carving out microservices so you can see what that looks like. Builder sessions are hand-on with Lambda and layers, things of that nature, and then some lightning talks. Overall, there's a whole lot of content on SaaS. Slight little plug for the SaaS Factory team, of which I'm part of. I encourage you to go look for the SaaS Factory team out on the AWS pages just because you'll find lots more SaaS content, lots of videos, lots of learning modules, other bits. Check out certification if you're here, if you're interested in getting certified, and that's it. Thank you so much for coming. Really appreciate your time. Enjoy the conference.